Hi, everyone, and welcome to AXA Arctic Live. It's wonderful to have you with us for this live lesson all about sea level rise. Now, it's an issue that will concern a lot of young people and a lot of people around the world. So we'll discover, using an activity, what drives sea level rise. But before that, we have a little bit of admin to get through, a brief introduction. We'll get into our activity, and then we'll have time for some questions and answers towards the end of this live broadcast. So we have schools from the UK, USA, France, Spain, Ukraine, and Thailand joining us this morning. Fantastic, and a very good morning to all of you. We have a special shout out, and that goes to Harrow International School in Bangkok, year 6 there. They are reading Floodlands in English and would like to know what causes sea level rise. So hopefully we will be able to cover that for you today. And also a big shout out to your English teacher, Mr. Corrie. Just in terms of the setup of these live lessons, you will probably see, if you're viewing this on the Encounter EDU website, that there is a Q&A app to the side of the screen. If you're watching on YouTube, you will need to be viewing this on encounteredu.com/live to make use of that functionality. Now, if you would like to have it full screen, don't forget you can also view the lesson on a secondary device, such as a smartphone or tablet, so a teacher can use that. Keep the live lesson full screen at the front of the class, and then pop any questions from students using a smartphone or a tablet. If you are experiencing any technical issues at all, or at any time during the live stream, please do click on the support button, and that is in the bottom right-hand corner of every page of the Encounter EDU website. So without further ado, I'm just going to introduce a little bit about what we normally do on Arctic Live, and then we'll get into a little bit of subject knowledge around ice. So unfortunately, due to the pandemic, I know a lot of you have been restricted in terms of movements and what we're allowed to do. It's no different for our science team and us getting up to the Arctic. But our normal base is the science village of Ny-Ålesund on the island of Svalbard, and that's halfway between the top of Norway and the North Pole. And it's a really wonderful place to be based. It's used to be a coal mining settlement and has now transformed into an international science village. And there's stations from a whole range of countries, from Norway, France, Germany, the Netherlands, Italy, the UK, Korea, Japan, China, India, among others. And it gives you a great sense that science really is an international endeavor. And for all those countries, there are buildings, places to stay, bedrooms, storerooms, laboratory facilities, boats, skidoos, everything you need to be able to get out into the Arctic, do your work, going through the sea, whether that's taking samples from a glacier, whether that's doing atmospheric calculations using lasers, there's a system called LiDAR. So a really, really wonderful place to get a sense of the cutting edge of monitoring our changing planet, and especially the changing Arctic. Now, the two ends of our world are the polar regions. At the top of the planet, we have the Arctic, and at the south, we have the Antarctic. And together, these frozen regions are known as the cryosphere. And these regions are being affected by climate change much more than the rest of the world. In fact, the Arctic is said to be warming 3 times faster than the rest of the world. But before we get into the impact of melting ice and its connection to sea level rise, let's just look at these regions. So the first image I want to share with you is an image of the continent of Antarctica. So Antarctica is a continent surrounded by ocean, and it's about just over 14 million square kilometers in size. Its predominant feature, of course, is ice, and the ice is on average about 2 kilometers thick, but getting up to 4.5 kilometers thick at its deepest point. Now, the amount of ice in Antarctica is truly astounding. There's an estimated 30 million cubic kilometers there. And someone will have to work out for me how many cubic kilometers that means for each person on the planet. Answers on a postcard, or in fact, answers into the question box, and we'll be able to see those come through. A little bit of maths to get you started. But the polar regions are dynamic. As the Earth wobbles on its axis, technical term wobble, but the tilt of the Earth changes through the seasons, what we find is that sea ice, and that's frozen ocean, becomes much more a feature. So if we look at Antarctica with winter sea ice there, you can see it stretching for about 7 million square kilometers, so another 50% of area during the winter, shrinking down to about 1 million square kilometers in the summer. So what we have, first of all, we have the ice on land on Antarctica, and then we have this sort of almost this sort of flow. Frozen sea expands during the winter and contracts during the summer. If we now move to looking at the Arctic, the area of the world where we are focused and where we've been working with scientists for the past 10 years, you can see this image here of the Arctic in the summer. Typical image, you can see that the Arctic is in fact an ocean surrounded by land masses. And really from the sort of left-hand side of the picture, going around towards the top, you can see Russia coming down to Alaska, Canada, Greenland, part of the Kingdom of Denmark, and then Scandinavia around the side, maybe a little bit of Iceland peeking out on the right-hand side, and then the tops of the Scandinavian countries, Norway, Sweden, and Finland. And in terms of this ice sheet, this mass of ice that you find in Antarctica, Greenland is the area you find that in the Arctic. Again, a huge, great mass of ice, on average about 2 kilometers thick, and at its deepest 3 kilometers thick, just over 3 kilometers thick. But sea ice is one of the dominant features of the Arctic, and it really sort of expands and contracts again on the seasonal basis. So the image you have at the moment is summer sea ice, and it's probably about sort of 2.5 million square kilometers. But if you look at a picture of it in the winter, what we find is that it's expanding sort of almost sort of 3 times, from about 2.5 to 6 million square kilometers. So again, this region of the world seeing frozen sea expanding and contracting on a seasonal basis. We can talk about some of those trends later, so it's maybe not getting as sort of wide in terms of extent during the winter and getting even smaller in the summer. And also the thickness of the sea ice is starting to change. We're going to do an activity in just a little bit, but I want to get some definitions down before we start. And there's going to be 3 definitions. The first one is land ice. Okay, so a lot of the ice, like we've looked at on the continent of Antarctica and on Greenland, is formed by falling snow and that compressing into ice under its own weight over the centuries and millennia. So if you see a glacier in another part of the world, that is also this type of land ice. Now, sometimes that land ice can break off into the sea, and we have land ice at sea. And land ice at sea, you might commonly call icebergs. And this is formed when parts of a glacier or an ice sheet meet the sea and fall off or crack off, or the technical word is calve. And that process of bits of ice breaking off a glacier front, for example, and going into the sea to form icebergs. Really amazing, amazing shapes and sizes, and quite wonderful to get not too close to, but quite close to. So an iceberg, although it is at sea, is not sea ice. The last type of ice we're going to talk about is sea ice. That is the process by which the surface of the sea freezes. So it's not coming from land, it is just the ocean freezing. Quite a wonderful process as it starts to get sort of oily, sort of nature to it. In fact, the sea doesn't freeze until about minus 1.8, minus 1.6 degrees Celsius, and that's because of the salt content. And then forming pans of ice, and then those pans knotting together and form a continuous skin. You do have potentially leads, breaks between ice flows, and these are quite difficult and pose challenges to those who are walking and exploring across this amazing environment. The activity we're going to look at today is looking at what happens to sea level when these different types of ice freeze. Sorry, not freeze, melt. Just catch myself there. For this activity, what you'll need is 2 containers. These are going to be your mini oceans. You'll need some cans to form your continents, drink cans, food cans, anything like that. You'll need a marker pen to mark the change in sea level rise, and you'll need some ice. Now, I've got my first ocean set up here, and what we're going to do is we're going to, first of all, I'm just going to reach down and get my bag of ice from down here in this hot, hot weather. And what I'm going to do is I am going to put some water into my mini ocean here. See that? I'm just going to mark a line, and this one I'm going to put land ice in, so I'm going to put all my ice on top of the continent. So I'm just going to put 1 piece there. That's 3 pieces. 6 pieces. I can put the same amount in each one. 7, 8. I'm just going to see if I can tilt the camera up just slightly so that you'll be able to see this a bit more clearly. I'm just going to find something to balance it with so we don't topple over. Is that a little bit better? There we go. So there we have 1, 2, 3, 4, 5, 6, 7, 8 pieces of ice on our continent, and we are going to leave that to melt and see how we get on. I'm just going to move that to one side. And we get our second ocean, get our continent in here, add our ocean water, And for this one, I'm going to draw the line after I've put the sea ice in. So I think we're looking at 8 pieces. So there's 1, 3 more, so that's 4, 3 more there, 7, and 8. Fantastic. And I'm going to draw my line. Make sure that's there. Draw my line. How good am I at drawing a straight line? Fantastic. So we're going to see if in our wonderful warm weather, we'll come back to these at the end of this live lesson. The reason being this needs a little bit of time to melt. I wonder if it's a ferociously hot day where you are. Ellie, who's behind the camera, who makes all these things work. Ellie, I think what I'm going to do is I'm going to put this both in a sunny windowsill, if that's okay. So if you could show our wonderful teams and classes watching some beautiful pictures of the Arctic. Just while I do that, it also gives you guys an opportunity, if there is a place in the classroom where your ice experiments will melt better, now's the time to move them over. Brilliant. So I'll go and grab those probably sort of 5-10 minutes before the end of the live broadcast. That is in about 15 or so minutes. We can have a look to see what's happened and discuss our findings and what we can conclude from that in terms of what will happen if ice melts to sea level rise. So we've got some wonderful questions coming in. When was the last time the Arctic ice disappeared? And that's from Harrow International School in Bangkok. It's a really great question. It's very hard to know. We weren't there, so we rely on records, both different types of cores, but often cores going into the earth to try and find out over time how the climate has changed. Now, our best estimates are that the last time the Arctic was sort of not frozen the whole year round, because there's still probably some ice in the winter, was about 2.6 million years ago. To give you a little bit of context, sort of modern humans have only been around for about 200,000 years. But yes, what that points out is that there have been climate cycles on the planet since its existence, about sort of 3.5–4 billion years ago, that the Earth goes through a series of natural cycles. And so the polar regions have been ice-free at periods in the past. I think what's most concerning scientists at the moment is the speed of the change as we come out of the last ice age. Really is the concerning the speed of change rather than the change in its bare sort of like happening instance. How long has the Arctic got at the current rate, how long has the Arctic got? It's a really interesting question to look at, and there's different ways of thinking about it. So if we think about sea ice, how long has the Arctic got? I think when people talk about that question, they're really, when will we see essentially a ice-free Arctic, a sea ice-free Arctic in the summer? And that's beginning to change already. So shipping routes are beginning to open up. Those currently are skirting the coasts around the north of Russia, being one of the more popular routes. But in terms of like going straight across the Arctic, I think the earliest estimate I've seen is about 2036, and sort of other scientists going towards 2050, 2060. But we really are seeing a thinning of the ice at the moment. You may have sort of had estimates in the past of sea ice being sort of 5, maybe even 8 meters thick at the North Pole, and that's coming down to sort of 2-3 meters. And I think the last thing is that as the amount of sea ice decreases, how long has the Arctic got? Sea ice decreases, puts pressure on life that relies on the sea ice. And 2 examples of that is one are the polar bear and the sea urchin or sea starfish. So first of all, the polar bear relies on the sea ice as its hunting ground. That's where the seals are. And so as sea ice melts, that's going to put pressure on those animals to find food. Another important role that sea ice plays is that you have algae, so microscopic plant-like sort of organisms growing on the underneath. They release sugars and dead cells into the water that fall to the bottom in a process known as marine snow. And animals that live on the bottom of the ocean, the Arctic Ocean, such as sea urchins and sea stars, rely on that falling food to keep them going. So as sea ice decreases, it reduces the food for a number of organisms. So there's a whole range of different roles that sea ice plays. We can go into the albedo effect if we've got a bit of time later on. So I'll ask the moderator to just give you a nudge on the albedo effect in a bit. How long has the Antarctic ice got at the current rate? It's. I think we're getting to a stage where there's a huge amount of ice in Antarctica. I mean, it's 90% of all the ice on the planet, and 70% of the fresh water on the planet is locked up in Antarctica. Yes, melt rates are increasing. Maybe in some parts of Antarctica, the increase in temperatures is in fact helping ice to grow in some parts. So that's increased precipitation, so snow falling actually adds to the total ice mass. So it's a very complex system. Overall, probably what we're seeing is, it's, by the end of the century, the melting of Antarctica could contribute to a sort of 40 centimeter sea level rise. But, if the whole of Antarctica melted, you're looking at a 60 meter sea level rise. I mean, the Antarctic's been sort of icebound, in essence, for over 30 million years. So we're not looking at an immediate ice-free Antarctica sort of anytime soon. Great question coming through is, will melting land ice make the ocean less salty? And will this affect sea animals? That's a really good question. So yes, melting land ice will make the sea less salty. Land ice is freshwater ice, and in fact, all ice doesn't have salt in it. When sea ice forms, in fact, it pushes the salt out of it, which allows the algae to grow on its base. Uh, um, you know, in terms of its impact on animals, there could be some impacts. The change in salinity also changes the chemical basis of the water, so that the pH drops, it becomes more acidic. So some of those changes, if they happen fast enough, could affect some of the life in the ocean. It's a whole range of complex interactions, and to find out more about the changing chemistry and how land ice melt could affect that, do join us tomorrow for lessons on ocean acidification. But one thing it certainly will affect, and this could have a knock-on impact on sea life, is ocean circulation. Now, yesterday we were looking at the fact that the Gulf Stream, this current that comes from the Caribbean all the way up to the Arctic, is affected or is driven by, in fact, dense, cold, salty water falling rapidly in the Arctic, creating a dragging motion, powering the ocean circulation system. If that water in the Arctic becomes fresher, that means that the strength of this falling motion may lessen and the drag may decrease, and this ocean current may slow or perhaps even stop. So the freshening of the Arctic Ocean is looking like it will have or could have a series of negative impacts. Really fun question from Harrow International School. How do you keep warm at night in the Arctic? That's a great question. So if you're camping on the sea ice, which we did 10 years ago, you have 4 sleeping bags. You have a vapor barrier line to stop any moisture from your body getting into the outer sleeping bag and freezing the insulation together. You then have a fleece sleeping bag. Then you have a huge sleeping bag that sort of like, takes up an entire suitcase by itself almost. And then you have a sort of like a sort of jacket for your sleeping bag to stop any ice falling and interfering with your insulation. One big secret for going to bed in the Arctic is that however much sleeping bagness you have, don't go to bed cold. Run around beforehand, get warm beforehand, because these sleeping bags are insulators. They don't make you warm, but they do keep you warm. So don't go to bed cold in the Arctic, or in fact anywhere else. And now going up to Nowlisson, you saw the pictures there before. We're very, very lucky to have a wonderful station with very nice, cozy bedrooms and everything else. So that's how we keep warm at night in the Arctic. You can't have fuel-based heaters in the tent because you can get carbon monoxide poisoning if those don't burn properly through the night. And so that's too big a risk. So yeah, unheated tents, lots of sleeping bags, and lots of sleeping mats underneath. What can we do? This is a great question 3. What can we do to protect the ice caps and reduce sea level rise? The ice caps are melting more because of increased heat on the planet, driven by increased carbon in the atmosphere. And so things that we can do are those that reduce the amount of carbon emissions. So there are 3 areas to look at, and that's really how you travel, how you eat, and how you live. So pick one of those and then think about how you can reduce your carbon emissions in that area. How do you travel to school? Can you choose a less carbon intensive form of transport? What do you eat? Can you choose a less carbon-intensive form of food? Think about things including packaging. Think about maybe becoming vegetarian for 1 or 2 days a week. The calorie intake from vegetables is far, far less than, the calorie intake from vegetables takes up or uses far less carbon and resources than getting the equivalent amount of calories from animals and animal products. So vegetables, think about becoming vegetarian for 1 or 2 days a week. Some schools are starting meat-free Mondays, for instance. And the last is how you live. What are those things you're consuming? What impact might they have? Do you leave things on standby at home? Do you always have your lights on? Is it so hot in your house during the winter that you can wear a t-shirt? All of those little things can add up. So those are a few things to think about. Are you worried by sea level rise? And what can we do about it? Am I worried about it? Yes, certainly. I mean, I think that a lot of these environmental issues are sort of risk analysis issues. If the planet is warming and we're losing ice, the rate of ice melt is, the rate of ice melt is increasing. If all the ice in Greenland and Antarctica were to melt, we would be looking at a 60 to 70 meter sea level rise around the world. So I'm not quite sure what level above sea your schools are at, but it is just quite astounding to think that, all that ice goes, we've got a 60, 70 meter rise, that would wipe out most of the world's, or pretty well all of the world's coastal cities and much more besides. So yes, I am worried. I'm not saying that's going to be a catastrophe that's starting soon, but if we take account of the risks into the future, then yes, I think it is something we should be thinking about. It is something that we should be acting so it doesn't happen, and that we safeguard, especially those communities, coastal communities, who maybe don't have the resources to build sea defenses to cope with that level of sea level rise. It sounds like we don't fully understand what the effects of sea level rise will be. Do you think this is dangerous? Do you think? I mean, this sort of touched on that. So hopefully, we've got that. Dangerous is in terms of flooding, storm surges reaching further inland. Can you just repeat again how big is Antarctica? Certainly. Antarctica is about just over 14 million square kilometers, and that's about twice the size of Australia. So to give you a sense of its size. We've got a question here come up with, what is the albedo effect? Ellie, I was wondering whether we can get the photograph of Svalbard sea ice up on screen. And I'll just talk through the albedo effect. Albedo basically just comes from the Latin for white. And the effect basically is that the solar energy is reflected back into the atmosphere by the white ice. And that's basically the albedo effect. What you can see in that image is those darker patches, I think, of sea, where there isn't ice. So dark colors tend to absorb more heat. You can do that. You can test that if you leave sort of white or dark paper in the sun, and you can or a sort of white or black car, whatever it might be, just to get a sense of the relative reflection and absorption of solar energy. So if you've got black patches, that's going to absorb more solar energy, which could lead to further ice loss. Further ice loss means that there's more dark, which means that it's going to absorb more, which is more dark, and that's what we call a feedback loop. And that is something that scientists are concerned about, is will those feedback loops start to reinforce themselves continuously? When do we reach a point where there's so much warmth in the ocean that it just continues to draw in more solar energy and melt more ice? Next question come up. Did you know that polar bears have to eat their own cubs? I think have to is a tricky one. It has been observed, very sadly, when there hasn't been enough food around. Other things that have been observed in terms of polar bears changing their diet, foraging from human settlements, eating lots of bird eggs, certainly on the shores over here in the summer. There are lots of migratory birds, and the polar bears will start to eat bird eggs and chicks and fledglings instead of seals. So yes, polar bears are having to change their diets, not always in towards eating their cubs, but there are a range of other adaptations they've had to do too. Ellie, I know we've got a chance for a few more questions to come through, but I'm going to go back and get my two mini oceans, if that's okay. So if you're going to share something on screen, just while I do that, and we'll see how the sea level rise has changed in my mini ocean and also in the ones in your classrooms. Hi there. So I've just gone to get my two mini oceans, and the one I've got in front of the camera first is the sea ice one. And so that's when we had the ice in the ocean. And as we can see, a lot of it's melted. I've just got sort of 4 tiny pieces left at the front here. But that has caused no difference in the sea level rise. And that is because this is a process by which the sea is freezing and thawing. So we do not expect to see any impact on sea level rise. So if you read in the newspaper or hear from someone that melting ice on the Arctic Ocean is changing the sea level rise, you can tell them, actually, I did a little experiment in my classroom, and that's probably not true. But let's look at the other mini ocean. So I'm just going to put that to one side, bring this one over, find where the line is. So we can still see that 1, 2, 3, 4, 5, 6 pieces of ice on top, although they're still sort of pretty melted, a lot of them. But we can see that even just in the past 15, 20 minutes, we have a discernible change in sea level rise. Ellie, do I need to move the camera back a bit just to get a little bit of focus there on with that? Okay. So we can see here, change in sea level just in the melt in the past 15, 20 minutes or so. So the conclusion that we can take from that is that melting sea ice will not affect sea level rise, but melting land ice, including glaciers carving off, forming icebergs and those melting, will affect sea level rise. And just to go back to those estimates, there's an estimate that if all the ice in Antarctica on the continent, the land ice, were to melt, that could increase sea levels by 60 meters. And then if all the ice in Greenland on Greenland were to melt, that could increase sea levels by about 6 meters. So I hope that's given you an overview of the different types of ice that you find in the polar regions, the different impacts they have were they to melt. Even though melting sea ice won't contribute to sea level rise, it will contribute to other issues such as potential lessening of the albedo effect, so more warmth being absorbed into the ocean, and also affects the habitat of many living things that rely on it for hunting and for their homes. Now, I think we've just got time for a couple more questions. The first is there internet in the North and South Pole? I think at the South Pole, yes. I haven't been to the Scott Amundsen base at the South Pole, but certainly there is internet around Antarctica. It's satellite-based internet. At the North Pole itself, there is, because it's there's no land there is no permanent base there. And so, although you could probably get satellite-based internet at the North Pole, in fact, where we are based in Nylund with that settlement, it is in fact, we have fiber optic broadband. And that is because there are various important experiments and sensors, some of which help to calibrate GPS globally. And so they're sending back sort of gigabytes, even terabytes worth of data back to science institutions around the world for them to work on those. So really, really important to have that data link for science, but it also enables us to communicate with the rest of the world too. Have I ever witnessed breaking ice or falling glaciers? Yes, I have. I think if we get a picture, I think of the Arctic glacier snout, you can see just at the front there are sections of ice coming off right down at the bottom. So you can see where the glacier meets the sea. And yes, not too close, because it can get a little bit dangerous if you're too close, because those falling bits of ice, that carving can cause huge waves. But it's a natural event. It's been happening throughout human history, and for much longer is this carving, these massive bits of ice falling off the front of glaciers. And it's simply stunning, simply amazing noise, and pretty stunning. Thank you so much for all your fantastic questions. Thank you for taking part in this live lesson. And I hope that you've learned a few things about sea ice, about setting up an experiment. I'm sure there's ways we could make it fairer in terms of making sure we exactly the same amount of ice, exactly the right amount of time, and various other factors to make it a fairer investigation, as well as getting exact measurements and that kind of thing. But little basic experiments, some fantastic questions from you guys. Do join us tomorrow for our final sessions from AXA Arctic Live, and they are on a changing Arctic Ocean, in particular its change in pH. How is the Arctic Ocean acidifying? Until then, it's goodbye from me. Bye-bye.